Okay, now this second part of protein synthesis is going to be looking at the translation part. Remember in transcription, DNA made a small snippet or a small piece of that messenger RNA that's going to carry the instructions on how to build that protein. It's going to carry it to the ribosome, outside into the cytoplasm, so outside the nucleus. In translation, what's going to happen is this ribosome, and remember it's made of codons, so 3 letters make up a codon, so it's made of these this segmented information. This messenger is going to carry that information to the ribosome. Okay, the messenger RNA and the ribosome speak different languages. Say the messenger RNA speaks only English and the ribosome speaks French. So there has to be something to help translate that information or make sure that they work together. Okay, and that the right information is picked up. That's where the translator or the tRNA is going to come into play. Okay, because they can't, the right information is there, they just can't understand each other. They need that translator. So tRNA is going to be the one that comes in and it can read those codons on the messenger RNA and translate it into the right amino acids that the RNA needs to build that protein. Here's a nice picture of what a tRNA looks like. Okay, at the top of this picture you can see the particular amino acid it's carrying, and here at the bottom it has something on it called an anticodon. And this anticodon, this part of the tRNA is what is going to be used to translate those codons on the messenger RNA. Okay, so how it works is you have the messenger RNA and you have its codons that make up those three letter segments that make up the messenger RNA. The tRNA is going to come along, and with its anticodon, it's going to read that message, that codon, and know what amino acid is supposed to go first, and then what amino acid goes next until you finish building that protein. Now there are 20 amino acids in all life. There are 20 amino acids, and they can be rearranged. The letters or the parts that make them, the nitrogen bases, can be rearranged to make these amino acids. And so you can actually get 64 different codes built off of these 20 amino acids. So here's how it works. You've got your RNA strand that was made from DNA, okay? And then right here it took all of the nitrogen bases that make up this piece of RNA and it broke it down into three letters to make a codon. So there's the first one, there's the second one, and so forth. Okay? What's going to happen is the tRNA is going to read those codons, and it'll know which amino acid to bring to the ribosome to allow the ribosome to build this protein. So let's look at this codon chart. Okay, this is what we have that we've put together as far as scientists go to know which codons code for which amino acids. And it's pretty easy to use. There are 3 letters that make up a codon. The first letter is going to start over here on the left side of the chart. The second letter you're going to look at the top of the chart, and then the third letter you're going to look at on this side of the chart, the right side. So for example, if you had codon UAC, you would come over here. The first letter was U, so you would start here. So you know you would be in this row. The second letter I said was A, so we're looking at UAC. So the second letter is A, so here's the second letter. So now we're in this box. And then the last letter is C. So we come up here. Here's UAC, which codes for tyrosine, the amino acid tyrosine. And that's how you use the codon chart. You look at where the letters are on your codon, and then you just follow the chart until you find your particular amino acid. Most amino acids are going to have 2 to 4 to 8 different codons that code for them. There's only 2 amino acids that only have one codon that codes for them. and it's the start codon, this methionine, okay? This start codon, AUG. There's only one codon that's going to code for methionine, and then tryptophan is the other amino acid that only has one codon that codes for it. Okay, if you look at arginine, there's quite a few. If you look at glutamine, there's more than one. If you look at proline, there's more than one. But methionine and tryptophan are the only ones that have just one codon. The way it works is the RNA is going to always start with a start codon, so the ribosome knows when to start, and it's always going to end with one of these three stop codons. Okay, so it's always going to start with AUG codon. That's the start codon to let the process know when to begin, and it's always going to stop with the process of building the protein with a stop codon. Okay, so here's how the process works. The ribosome is going to, or the tRNA is going to read the codon. It's going to bring whatever amino acid goes with that particular codon. And then as it moves through the ribosome is going to build or connect these amino acids together until it's finished reading all of the codes, making its polypeptide as an end result. Here's a nice picture. Once again, it goes through the steps of how it works. Okay, so you can always look at this later, but once again, when I said it knows, the ribosome knows when to stop building that protein, because at the end of the RNA, there's going to be a codon that's going to tell the ribosome that you're done. This protein is finished being built, and it'll be one of these three stop codons: UGA, UAA, or UAG. Okay, so let's review translation. In translation, what's going to happen is the messenger RNA that came from the nucleus is going to meet up with the ribosome. tRNAs are going to read those codons that make up the RNA, and then the ribosome is going to build those amino acids together, connect them together, building that polypeptide, that protein. And the tRNA's job is to bring the right ones that are needed to build that particular protein. Okay. And then looking at these pictures, you can look. Okay, you can see, for example, this one. Here's the ribosome. It's reading. It's moving along through across the RNA. These anticodons are bringing whichever amino acid matches up with that particular codon on the RNA. The ribosome is helping build, and these polypeptides get really, really long and complex, but eventually you get protein synthesis as a result. Starts with the start codon, that methionine, and always ends with one of those three stop codons until you finally get your polypeptide or your amino acid, or your polypeptide or your protein built. Now, here's just a one little basic overview snapshot. You're going from DNA to protein. We know DNA through the transcription process is going to make RNA. Okay, it's going to carry that code out of the nucleus to the ribosomes in the cytoplasm, where tRNAs are going to help translate along with the RNA, or along with the ribosome, and build your polypeptide chain until eventually your protein is finished and the process is complete.